In this first part, let's start by checking the resistance of our wires using a basic ohm meter. Here is the first wire, a coil wire with 0 ohms of resistance. As you can see, the meter shows a clean 0. Now switching over to our second wire. This one has a built-in resistor. The multimeter shows around 1.6 kilo ohms. This difference might seem small, but it plays a big role when it comes to electrical noise, especially in cars running standalone ECUs like this one from Levin Tuning. Now let's take it to the car and see how this affects real-world performance. We've set up the 0 ohm coil wire, marked in red. Start the car and watch the laptop display. See that electrical noise? That interface can cause false readings, misfires, or sync issues. Now we switch to the 1.6 kilo ohm wire. Same setup, same sensor. Now, this time, look at the data. Clean signal. That resistor does a great job filtering out the unwanted noise without affecting performance. So what's really going on here? VR sensors generate signals that are sensitive to interference, especially from coil wires running near ignition or alternator wiring. A resistor in the wire acts like a damper. It helps block high frequency noise. And no, it doesn't affect the spark or cause weak ignition. The resistor is small enough that it won't interfere with firing voltage. But here's something important. The resistor should be at one end of the wire, not built into the middle. That's because if you have a different length of wire, the effective resistors will vary, and that inconsistency can mess with tuning. So use a wire with consistent low resistance and add a resistor at the sensor connector or ECU side where it's easy to control. If you are running a standalone ECU setup like Levin Tuning, don't ignore this little detail. Swapping your coil wire for one with the right resistors can mean the difference between smooth tuning and hours of frustration chasing noise. It's cheap, it's simple, and as you've seen, it works.